Hey everyone, I want to talk to you guys a little bit about the rock cycle and formation of rocks. So here's the rock cycle, and as you can see, there's not really anywhere you start in particular. Igneous rock, if it gets weathered and eroded, can become sediments. Those sediments can then get compacted and cemented into sedimentary rock. That could be weathered again, turned back into sediments. Or if it's subjected to heat and pressure, it can become metamorphic rock. Then metamorphic rock can go back to sediments and become sedimentary rock, or it can melt, become magma, which then cools and becomes igneous rock. Igneous rock can also become metamorphic rock. So all of these are really tied together. And here's just another visual of that process. Right, so here's the magma cooling and becoming igneous rock. Here's rock that is being weathered by elements into sediments, and then those sediments are being compacted into sedimentary rock. They're subjected to high temperatures and pressure and turned into metamorphic rock. So we'll start with sedimentary rock, right? So sediments are little pieces of rock that get weathered away, right? So something breaks apart a rock into little tiny pieces. Those sediments, those little tiny pieces, then get washed into the water, blown in by wind, right? And then those sediments end up on the bottom because they sink. And over time, you get layers of this sediment forming. If you can imagine when you were in grade school making a pyramid with your friends, right, the people on the bottom of the pyramid are going to be subjected to a higher amount of pressure. So these layers of sediment that are on the bottom that have all this pressure from layers on top of them, right, they get squished together. So here's the sediment, right? And then as the layer gets buried by other sediments, those sediments become compacted, right, by increased pressure. So all this water and air gets squeezed out, and then the actual pieces of rock get pressed closer together. The more pressure that is exerted on these sediments, right, the more the grains get pressed together, and eventually it leads to cementation, right, where those particles are so pressurized that they actually get glued or cemented together. And then those pieces of sediment get changed into rock. The process of making rock is actually called lithification. Right? Lithification means the making of stone. Right? And the cementation process happens because as those sediments are pushed together, you get some dissolved substances that precipitate out and act as the glue. Right? Those get pushed together. Some substances dissolve out and precipitate out and act as the glue, keeping those pieces together. These sedimentary rocks usually form in water, and this is the most common rock on the surface of Earth. So here's just some examples of sedimentary rock. You can place sedimentary rocks into three categories depending on what the sediments were that make up the then sedimentary rock. So clastic sedimentary rock is where you get pieces of other rocks that then get squished together and turned into sedimentary rock. Right? So a rock gets worn away, those pieces of the previous rock get glued together and make this new clastic sedimentary rock. And within that clastic sedimentary rock, you can have coarse, medium, or fine-grained rock. So like sandstone is a medium-grained clastic sedimentary rock. Chemical sedimentary rocks, like down here, occur because of the precipitation of dissolved minerals, right? So like calcite is where you get precipitation of calcium, and then that calcium dissolved mineral can all those pieces of calcium can get stuck together and create the chemical sedimentary rock calcite. Halite is like rock salt. So salt precipitates out. That water then evaporates and leaving behind the salt, and then all those pieces of salt get glued together, creating halite. Organic sedimentary rock is a rock that is made up of the remains of once living things. Right? So limestone comes from calcium carbonate shells. So those shells get broken up into pieces. They used to be alive, they get broken up into pieces, and then those pieces, those small pieces of shell, get glued together, creating limestone. Plant matter that has then died and is kind of in the process of decomposing, it can get stuck together and create coal. Right, so organic sedimentary rock is the remains of once living things. So these three different types of sedimentary rock are based on what the sediments were made up of. Right, so clastic was pieces of rock, chemical is dissolved minerals, organic is once living things. So metamorphic rock are rocks that change form while remaining solid. Right? So you start with either a sedimentary rock or an igneous rock, and that igneous rock or sedimentary rock gets changed by heat or pressure into a metamorphic rock. So here, right, you have the sand, which is the sediment. That sand gets gets pressure exerted onto it and turns into sandstone, which is the sedimentary rock. That sandstone then gets more heat and pressure applied to it, becomes metasandstone, and then the metamorphic rock quartzite. Right, so here you're starting with a sedimentary rock. That sedimentary rock sandstone has heat and pressure applied to it, and then it becomes quartzite. Lime mud, those pieces of that chemical sedimentary rock, right? Those pieces of shells get pressure and heat exerted on them. They turn into the sedimentary rock limestone, and then that limestone becomes marble. Okay. Granite is an igneous rock, and then that granite, that igneous rock, has heat and pressure applied to it and becomes the metamorphic rock gneiss. Right? So if you think metamorphosis, like butterflies, right, you're getting the change from one type of rock to another because of heat or pressure. That heat is coming from the internal heat of the earth or near a magma chamber. That pressure is coming from overlying rocks or tectonic plate movement. Right. So there's two main categories of metamorphic rocks. There's foliated and non-foliated metamorphic rocks. So granite is this igneous rock. Right. That granite then gets squished down to create gneiss. Right. So foliated metamorphic rock is where you have pressure is the main factor in metamorphosizing that rock. So if you look at all these big crystals in the granite, when pressure is applied to that granite, those crystals get flattened out into gneiss. Right? So all of these big crystals, these big circular crystals, are now these flatter crystal layers. So if you can think foliated, flattened. Foliated metamorphic rock has a higher amount of pressure being applied to it rather than heat. Right? So pressure is the main factor in creating that metamorphosis. Non-foliated metamorphic rock is created to a higher degree by heat. Right? So here is that limestone, which is that sedimentary rock. That limestone has a large amount of heat applied to it, and that heat kind of changes or crystallizes that limestone into marble, which is this. Right? So all metamorphic rock has heat and pressure applied to it, but foliated, flattened is a higher amount of pressure. Non-foliated is a higher amount of heat. Here's our igneous rock. Igneous rock are rocks formed from the cooling and crystallization of magma. Right? So magma is molten rock below the Earth's surface. Lava, like from a volcano, is molten rock that has reached out of the Earth's surface, that reaches and flows out onto the Earth's surface. Right? So there's actually two types of igneous rock. You guys are probably most familiar with igneous rock that comes from a volcanic eruption. Right? So extrusive igneous rock, these are rocks that have come from lava, right, or magma coming out of the Earth's surface, and then it rapidly cools, right? So obviously the temperature difference between here and then than here is going to be quite large. So when magma gets pushed out through the Earth's surface, it cools very rapidly, and it leads to very fine, small-grained rocks. So extrusive, you can think of exiting the Earth's crust. Extrusive igneous rock is very fine, small-grained rocks. Right? So this would be an extrusive. So you look for really tiny crystals. Right? Because since it cools so quickly, it doesn't have time for really large crystals to form. The crystals can form so quickly and be so tiny that it actually looks like glassy. Right? So this is basalt. But if it cools really, really quickly, the crystals are so small that it looks more glassy. And a good example of that would be like obsidian. Obsidian is this smooth, shiny black rock. You can also have intrusive igneous rock. So this is rock that forms inside or below the Earth's surface. Right? So here you have a magma chamber, and then some of this magma leaks into this igneous intrusion, right? And you get the cooling of that magma below the Earth's surface. Right? So since the temperature difference isn't as large, this is able to cool much more slowly, and since you have slow cooling, you get really large crystals that are able to form. Right? So you still have the melting magma that's forming this igneous rock, but that is formed underground, so less of a big temperature difference, so you can get the formation of large crystals, like in this granite. So those granite countertops that people really like because they have really large crystals, right? That's because of this slow cooling. Right? So here's just some more examples of igneous rock, right? So you get extrusive, fine-grained, cools really quickly, right? Something like rhyolite. This is like a reddish brown igneous rock. Basalt, which is you're probably more familiar with in terms of like lava rock because it's dark in color and has really tiny crystals. Intrusive, coarse grained, so cools slowly. You can get the formation of large crystals. Probably most familiar with granite. So the mineral composition of the igneous rock can determine the color. So really sodium rich, you'd get something more like quartz. You get more calcium rich, you'd get something like olivine. So one last thing with this rock cycle is this law of superposition. Right? So when we're looking for fossil footprints or sand ripples, right, you can imagine that those are always going to form on the top of a layer. They're going to form on the top of a layer, right? Because something imprints on the top of a layer and then that imprint gets buried, right? So a bone or a footprint, right, gets laid down on the top of a layer and then that layer gets buried. So you would expect to find these fossils on the top of a layer. But what can happen, so in general, when you get these layers of rock, you know that the deeper the layer is, the older it is, right? That makes sense because newer layers are going to get laid down last. But what can happen is you can have these events where the rock actually gets overturned, right? Something like this. And then that whole younger rock, older rock being buried deeper can get a little bit more complicated. You know that this overturning has happened if you start to see fossil footprints and sand ripples on the bottom of a layer. Right? So if you see them on a bottom of a layer, you know that the rock has been overturned. Fossils are only found in sedimentary rock. During this lithification, this stone-making process, parts of the organisms are replaced by minerals and then slowly turned to rock. So when you find a fossil dinosaur, that's not the original bone. That bone has been replaced by minerals that slowly turn into rocks. And then you can determine the age of those fossils through relative dating of the rock layers or the fossil itself. So you only find fossils in sedimentary rock because if it was igneous rock, that's the cooling of magma, right? So if you get a volcanic eruption that then buries a dinosaur, say, that really, really hot magma would destroy the dinosaur and you wouldn't get anything left. And then metamorphic rock is the change from sedimentary rock, or igneous rock, so because of heat or pressure, so you wouldn't be able to see that fossil because it would have changed from the sedimentary rock. Sedimentary rock is the only case where you would get something buried. And that is all for the rock cycle.